Alright, ladies and gentlemen, this is Mr. Anderson for Kellogg Community College with the fifth of 5 videos talking about Chapter 3, Section 4. We're going to establish each identity function here, and what we're going to say is we've got 1 plus, if all we have to work with is 1 plus sine of theta and 1 minus sine of theta. We've got to get this secant theta plus tangent of theta. How are we going to do this? Well, everything's in terms of sine or cosine, so that option's out. Common denominators doesn't seem like a good strategy, but what I will do then is probably try to get a difference of squares. So let's operate on the bottom one here and make this 1 plus sine of theta. All right, so if we multiply top and bottom by 1 plus sine of theta, all right here, and what we get is we got 1 and 1, which makes 1, and we have sine, and, well, actually, here's the thing. Instead of foiling this, why don't I just write down 1 plus sine of theta, quantity squared. Maybe this will get me somewhere in the end. And down here, I've got a difference of squares here, so this is 1 minus sine squared theta. Now, this strategy that I'm using is going to come to fruition for a little bit because the 1 minus sine squared theta, this is equal to cosine squared theta. And in the top right here, we still have 1 plus sine of theta quantity squared. And in kind of a neat little trick here, what I'm going to do is take my denominator and change that into cosine theta squared. And now I have my numerator as 1 plus sine theta quantity squared. And through power rule, actually technically a quotient rule since these are being divided, we can actually put these all under the same bracket here, 1 plus sine of theta over cosine theta quantity squared. Now this gives me that little square on the outside that I'm looking for, so now I got to trade the inside in for secant theta plus tangent of theta. That's pretty easy because I can, since this is a monomial, I can go 1 over cosine of theta plus sine over cosine of theta quantity squared, and there you go. There's my secant of theta, and here is my tangent of theta, and the whole thing is squared just like that. So there we go. We've established that identity. For problem number 22, it's going to be a little intimidating here, but one of the neat little aspects is if you take a look at the negative tangent squared v. Now what's interesting about this is that if you take secant, this negative tangent squared v, and this secant squared v, and you look at one of the established identities, you would see that this whole thing right here is equivalent to 1. So 1 plus tangent of v is equal over secant of v. And this right here is pretty nice since we are going to be able to break this down pretty nicely, but you're going to see that if this would be best to turn everything into sine and cosine, because we got 1 plus sine of v over cosine of v over, because notice we have our answers in sine and cosine, and then we have 1 over cosine of v. So let's get common denominators in the numerator. So I'm going to multiply this left-hand side by cosine over cosine. This is going to give me cosine v plus sine of v over cosine of v. And then I'm going to have 1 over cosine of v. Now if I skip, flip, and multiply and move this to the top, as shown in other videos earlier in this series, I have cosine of v plus sine of v divided by cosine of v times cosine of v over 1, and these simplify, leaving me with cosine v plus sine of v, and using the commutative property, we have sine of v plus cosine of v. Woo! Now that is 2 of our 5 problems here. We got 3 more to go. So problem 23 here, it looks like we have a lot of things with sine and cosine. We got some subtraction there. So the strategy for this one, and there's multiple ways to do this problem here, but the one way I like doing it is maybe breaking all these up. And in breaking all these up, I've got sine of theta over sine of theta plus cosine of theta over sine of theta minus cosine of theta over cosine of theta. Now this is important. This would be a plus sine of theta over cosine of theta. Now why that is because this whole fraction is being subtracted. So this would be minus cosine theta over cosine theta, and the negative and negative make a positive. So what does all this break down to? What this all breaks down to is going to be, pretty nice here, because now that we have all of this, we're going to have our 1 plus, in this case, cotangent theta minus, in this case, we've got 1 plus tangent of theta. And so with our 1 and 1 simplifying, now I have cotangent theta plus tangent of theta. And we're still not close to this, are we? We're still not quite there yet. So now I have to think to myself, gee whiz, what could I possibly do here? Well, one thing I can possibly do is I can take this and break this back into sine and cosine. So this is going to be cosine x over, cosine theta over sine of theta plus sine of theta over cosine of theta. It's probably best to get a common denominator and add these two fractions together, because I'm supposed to get something like this. So what I'm going to do is multiply this fraction here by cosine over cosine. So this is going to be cosine squared theta. And the denominator will eventually become sine theta cosine theta. And this over here, this is going to be, I'm going to multiply it by sine over sine, because I need that common denominator. So this is going to be sine squared theta over the sine theta cosine theta. And lo and behold, look at my numerator. Cosine theta plus cosine squared theta plus sine squared theta, that's equal to 1. And my denominator is going to be our sine theta cosine of theta. And we're going to split this up. 1 over sine of theta times 1 over cosine of theta, which is going to be my cosecant theta secant theta. And I can flip these around using the commutative property, secant theta cosecant theta, just like it was up in the problem. Now the book will probably have done this a different way, but I like to have crushed this down to tangent and cotangent again, and then break that down. And you might have actually done this problem earlier in your homework, so please check back and look for that. All right, 2 more to go. Let's see here. We've got a problem that we're going to have to break down to cosine or cotangent theta plus cosine squared theta. Boy, where do we even start with this? Well, since all of these are getting divided by sine, let's just see what happens. Let's go with cosine theta over sine of theta plus sine of theta over sine of theta. Something good might happen here. Minus, now here's the funky one, we got sine cubed over sine of theta. Now again, there is some manipulation to rewrite this as sine theta cubed and then simplify that with the one below it, but we're going to be doing a little shortcut here, because this is going to be cotangent theta, which is good because that's right there. This is going to be 1, so that's good. And then this will simplify that to make it down to 1 minus sine squared theta, and this can be changed into cosine squared theta. So the cotangent theta plus cosine squared theta, we just established that identity right there. So for our final problem today, we have this 1 minus 2 cosine squared theta, and I've saved a tough one for the last problem, because I doubt many of you would have seen this problem as 1 minus cosine squared theta minus cosine squared theta. I doubt you would have taken that step, and the reason why I doubt you would have taken that step is because you probably wouldn't have thought about separating this out, this 1 minus cosine squared, all over sine squared cosine squared. Or sine squared cosine. Yeah, there's no squares there. Sine theta cosine theta. There we go. Now I said it right. So 1 minus cosine squared theta. Well, that happens to be sine squared theta. Now that sine squared theta, we can subtract cosine squared theta, And we're still going to have this over sine theta, cosine theta. But now, since this is considered a monomial, we'll break this up. We'll just say, okay, this is sine squared theta over sine theta cosine theta minus cosine squared theta over sine theta cosine theta. And now we'll do some simplification. So this first fraction right here, this is going to be sine of theta over cosine theta. And the second fraction here is going to be minus, let's see here, cosine theta, because see the sines canceled out, leaving 1 on top. Cosine simplified, leaving 1 on top. So this is cosine theta over sine theta. And oh my gosh, check this out. This is going to be tangent theta minus cotangent theta. And we are, congratulations if you've been through all 5 videos or got through the entire worksheet. I encourage you to do the homework assignments solved, because the more you do them, the better you get. And you can go and do them 2 and 3 times, and you will get better and better every time you do them. Thank you for working so hard. This has been Mr. Anderson for Kellogg Community College for Chapter 3, Section 4, Establishing Identities.